determine the appropriate kilovolt ampere, or kVA, rating for a transformer connected to a 480 volt Variac rated at 70 amps, which steps down the voltage to 240 volts with an approximate secondary current of 140 amps. We need to use the transformer kVA calculation formula. The formula to calculate the kVA rating of a transformer is kVA equals the primary voltage, represented as volts 1, multiplied by the primary current, represented as amps 1, all divided by 1000. In mathematical terms, this is expressed as kVA equals volts 1 times amps 1 divided by 1000. We are given that volts 1, the primary voltage, is 480 volts and amps 1, the primary current, is 70 amps. Substituting these values into the formula, we get kVA equals 480 times 70 divided by 1000. Calculating this expression, 480 multiplied by 70 equals 33,600. Then, dividing 33,600 by 1000, we get 33.6 kVA. Therefore, the preliminary kVA calculation is 33.6 kVA. Since the transformer is a step-down transformer, reducing the voltage from 480 volts to 240 volts, the secondary current will be higher than the primary current. The relationship between the secondary and primary currents is determined by the inverse ratio of the voltages. That is, the ratio of the secondary current to the primary current is equal to the ratio of the primary voltage to the secondary voltage. The formula to calculate the secondary current, represented as amps 2, is amps 2 equals amps 1 multiplied by volts 1 divided by volts 2. Here, volts 2 represents the secondary voltage. In our scenario, volts 1, the primary voltage, is 480 volts. Volts 2, the secondary voltage, is 240 volts, and amps 1, the primary current, is 70 amps. Substituting these values into the formula, we have amps 2 equals 70 multiplied by 480 divided by 240. First, we calculate 480 divided by 240, which equals 2. Then we multiply 70 by 2, resulting in 140 amps. This confirms that the secondary current amps 2 is indeed 140 amps, as stated. Therefore, based on the primary voltage of 480 volts and a primary current of 70 amps, the transformer should be rated for at least 33.6 kVA to adequately handle the load and produce approximately 140 amps on the 240 volt secondary side. It's crucial to ensure the transformer's kVA rating meets or exceeds the calculated value to prevent overloading and ensure safe and efficient operation. Considering that transformers typically have standard kVA ratings, selecting the next higher standard rating above 33.6 kVA would be advisable to provide a safety margin. This ensures the transformer operates within its design limits, even under varying load conditions. Furthermore, it's important to check the transformer's specifications, including the insulation class and temperature rise, to ensure it's suitable for the intended application and environmental conditions. Additionally, one should consider any potential harmonic content in the load current, as harmonics can increase transformer heating and potentially require a larger kVA rating. Consulting with a qualified electrical engineer can help in making an informed decision about the appropriate transformer size and specifications for a given application, especially when dealing with nonlinear loads or unusual operating conditions. Also, remember to account for any future load growth when selecting the transformer kVA rating. Oversizing the transformer slightly can provide additional capacity for future expansion without requiring a complete transformer replacement. In summary, to determine the kVA rating of a transformer, firstly use the formula kVA equals volts 1 times amps 1 divided by 1000, where volts 1 is the primary voltage and amps 1 is the primary current. Secondly, calculate the primary kVA using the given values. In this case, kVA equals 480 volts times 70 amps divided by 1000, which results in 33.6 kVA. Thirdly, verify the secondary current based on the voltage ratio. The formula is amps 2 equals amps 1 multiplied by volts 1 divided by volts 2, where amps 2 is the secondary current and volts 2 is the secondary voltage. Fourthly, confirm that the calculated secondary current matches the desired output. In this case, amps 2 equals 70 amps multiplied by 480 volts divided by 240 volts, which equals 140 amps. Fifthly, select a transformer with a kVA rating at least equal to the calculated value, considering factors like future load growth, harmonic content, and environmental conditions. Therefore, a transformer rated for at least 33.6 kVA is required for this application.